Hello, a very good morning to all. Now, in this lecture, we will deal with the homogeneous linear partial differential equation with constant coefficient. First, homogeneous, let me explain first, right? Why this is homogeneous, right? This is homogeneous linear partial differential equation with constant coefficients, right? So here homogeneous, why? Because this you can say right. See, right hand equal to always 0. You can make it here. You can make here r minus a square t equal to 0. So this is also homogeneous, right? Now linear, why? Because in this case the means you can say degree of each hard derivative is 1. Degree of each derivative is 1. So this is linear and there is no multiplication with the dependent variable and its differential coefficients, right? So and constant coefficient, because you can check the coefficient of r, t and s, these are constants. You can check 25 r, 40, right? So that's why this is called homogeneous linear partial differential equation with constant coefficients. Okay, so I'm going to solve here these four problems of homogeneous linear partial differential equation with constant coefficients, right? So let's start. Now the first problem, let me tell you, we have r plus t plus 2s equal to 0, right? Now let me tell you where r is equal to what? d over square z over d over x square, and t is what here? D over square z over d over y square. Yes is what? D over square z over d over x and over, right? Now see, also we can write here, let me tell you, r is equal to d square z. In this case t is equal to, we can write, so we can write here d dash square z, and this yes can be written as d dash z. You have to replace the derivative with respect to y by d dash and the derivative with respect to x by only d, no dash, right? So now the given equation can be written as how? This is d square plus d dash square plus 2d into d dash, and take common, that is z. So this is homogeneous linear partial differential equation with constant coefficient, right? Now we have to solve this. अब हमें इसे क्या करना है? सॉल्व करना है. बनाएंगे क्या? auxiliary equation. First of all we have to write the auxiliary equation, right? Auxiliary equation, to get auxiliary equation what have to do? हमें क्या करना है? You have to replace this capital D equivalent to small m and this capital D is equivalent to 1, right? So this is what? M square plus 1, m square plus 1 plus 2m equal to 0, right? This is auxiliary equation, m square plus 1 plus 2m, right? You can write this is m plus 1 whole square equal to 0, right? So we have m equal to minus 1 and minus 1. So in this case, let me tell you one thing. This solution, that is z, will be consisting of CF, complementary function, plus particular integral PI. But the given equation is homogeneous. Given equation is homogeneous. So there will be no pi. There will be no pi. Only the solution will contain CF complementary function. Right? So complementary function, how to write the complementary function? And so this is CF complementary function will be what? Now, first of all, a complementary function will depend on the types of roots, whether the roots are distinct, whether the roots are repeated, right? So here we have two roots, -1 and -1. So this is the case of repetition rule, right? So you have, let me tell you, suppose the roots is repeated, m1 is repeated, so you have to write here y plus m1x plus x time phi 2 y plus m1x. This is the way if we have two roots m1 equal to m2 and both are same. So you have to write this way the complementary function, right? So in this case we have complementary function phi 1 y m1 is minus x minus 1 plus x time phi 2 we have minus x, right? So this is the solution, that is z is equal to cf. So phi 1 y minus x plus x times phi 2 y minus x, right? So this is the solution, right? So this is the solution. Okay, now see next problem we have here d cube minus 4 d square d dash. We have, wait a minute, sorry, yes, we have d cube minus 4 d square into d dash plus 4 d dash square z plus plus 4 d dash square into z equal to 0. This is what we have to solve. Okay. Now again, in this case, the question is already written in the form of operators. Operators means d and d dash. So in this case, you have to write a general equation. Auxiliary equation, you have to replace here capital D by small m and d dash by 1, right? So this become here m cube minus, right, 4 d dash square, so 4 m square, right, plus we have 4 m. I'm not writing here 1, right, d dash is equal to 1, so this is minus 4 m square as per equal to 0. Now in this expression you can take common m, so this is m square minus 4m plus 4 equal to 0. Dear student, this is very well known formula. I am going to write here, this is m minus 2 whole square equal to 0, right? Now, so we have roots here 0, okay, 2 and 1. So this is equation is homogeneous. So the solution will be consisting only one part, that is complementary function. That is complementary function. So now write this complementary function, that is C. First of all, I am going to write here phi arbitrary function of this root y plus 0x, y plus 0x. So 0 into x, that is 0. So we have only y plus. Now the case of repeated root. So this is phi 2 y plus 2x plus x times phi 3 y plus 2x, right? So this is the complementary function, that is our solution. That means z equal to, we have here phi 1 of y plus phi 2 of y plus 2x, and this is again we have phi 3 of y plus 2x. So this is our solution, right? Now let's see the problem number third we have, that is r is equal to a square t, right? R is equal to a square t. We have third problem, r is equal to a square t, right? It's okay, very simple. R equal to, you can write derivative square z over derivative x square. You can write this is a square, so derivative square z over derivative what, y square. So I can write here derivative square z over derivative square minus a square derivative square z y square equal to 0, and this can be written as d square minus a square d dash square into z equal to 0, right? यहाँ कैपिटल D स्क्वायर माइनस ए स्क्वायर कैपिटल D रेस स्क्वायर which is equal to 0. So this is the problem we have, right? Now, so the solution, how can you write the solution? In this case you have to write here the auxiliary equation. The auxiliary equations we have here, replace here capital D by small m and d dash will be 1. So we have m square minus a square equal to 0. So we have m equal to plus minus a. So now the complementary function here, this is what, phi 1 y plus ax plus phi 2 y minus ax. Also now I am telling you, this is what, homogeneous linear partial differential equation. So the solution will contain only complementary function, that is z equal to phi 1 y plus ax plus phi 2 y minus ax. So this is the solution, right? Now write down fourth problem we have, 25r minus 40s plus 16t equal to 0. 25r minus 40s minus 40s plus 16t equal to 0. So this is the partial differential equation we have. So we have to solve this, right? Now I think the notation already I have told you. You can write 25 derivative square z over derivative square minus 40. This s means what? Derivative square z over derivative x and derivative y plus 16 t, right? This is what? Derivative square z over derivative y square. Okay, is equal to 0. Right? Now, so that's very simple. You can write here this is 25 capital D square minus 40 d into d dash plus 16 d dash square, okay, into z equal to 0. This is we have. Now again for auxiliary equation you have to just replace here capital T by small m. So this is m square minus 40 m and d dash by 1. So we have 16 equal to 0. Now I am telling you this is what 5m minus 4 whole square equal to 0. Right? So you have here m equal to 4 by 5 and 4 by. Is that clear? Right? So these are the repeated case. So the complementary function will be what? Phi 1 y plus 4 upon 5 x plus phi 2, sorry, plus x times phi 2 y plus 4 upon 5x. So this is the complementary function and that is our final solution. So you can write z equal to phi 1 y plus 4 upon 5x plus x times phi 2 y plus 4 upon 5x. So this is the solution. Okay, so bye, take care, God bless you all, have a good day. We'll meet you with the next problems.